In this video, we're talking about confidence intervals for mu when sigma squared is unknown. So mu is unknown and sigma squared is unknown. So in the previous video, I said that if you want to have a 1 minus alpha times 100% confidence interval for mu, that is going to be x bar plus or minus this specially chosen quantile from a t distribution with n minus 1 degrees of freedom, so that we have alpha over 2 in the tail, times the sample standard deviation divided by the square root of the sample size. All right, so if we want to prove this theorem, then essentially what we want to show is that 1 minus alpha times 100% of confidence intervals formed in this way here are going to cover mu. So we'll do the same thing as usual. We take our distribution. So recall that x bar minus mu divided by s over root n has a t distribution with n minus 1 degrees of freedom. So what we do is draw out this t distribution with n minus 1 degrees of freedom. And since we want a 1 minus alpha times 100% confidence interval, we put 1 minus alpha in the middle. And then we want to have alpha over 2 in each tail. So we go out and find this cutoff here, and maybe we call it negative t alpha over 2, and this one is positive t alpha over 2, so that we have alpha over 2 in each one of these tails. And since the t distribution is symmetric, centered at 0, it works out that they're just the positive and negative of each other. All right, so we've gone out and selected these t quantiles. So we selected it so that the probability that a t distribution with n minus 1 degrees of freedom is less than or equal to negative t alpha over 2 is 1 over 2. Sorry, alpha over 2. All right, so we specially selected those t alpha over 2 so that we get this probability. So then we know that the probability that a t distribution with n minus 1 degrees of freedom is between negative t alpha over 2 and positive t alpha over 2 is 1 minus alpha. That's how we set it up. All right, but what has a t distribution with n minus 1 degrees of freedom? This quantity, x bar minus mu divided by s over root n. So let's go ahead and write that in there. So the probability, and we're going to keep these two quantities the same, these two quantiles the same, the probability that x bar minus mu divided by s over root n is between negative t alpha over 2 and positive t alpha over 2 is still 1 minus alpha. Now we do the same thing as we have done in all the previous videos, and we just solve for mu. So we just rearrange this inner thing inside the parentheses so that we have mu in the middle, and we'll end up with x bar minus t alpha over 2 times s over root n as our left endpoint, and then x bar plus t alpha over 2 times s over root n as our right endpoint. So now we've done exactly what we're trying to show. The probability that mu is going to be covered by this random interval with this endpoint and this endpoint is 1 minus alpha.